Hello everyone, welcome to today's class. Today we have a very nice math challenge before us. So how do we solve this challenge here? The question is y to the power of 3 minus x to the power of 3 equal to 91. We have been told that we should look for x and y within the domain of what? Integer. Okay, so we have to look for the integer values of our x and y. So how we solve this is easy. So let's take our solution from here. So we see solution. First thing first, okay. Now, here, if you share this very well, you can see or spot out what we call the difference of 2 cubes on the left-hand side of the equation. And what does that say? It says that if you have your a to the power of 3 minus b to the power of 3, this is equal to our a minus b close bracket or into our a to the power of 2, there plus our a, b, there plus our b to the power of 2. Remember this? Okay. Now, we can rewrite the left-hand side of this equation in this format. So, we're going to take it from this format to this format. So, this term will give us, or this now implies, bracket our y minus x, close bracket, there bracket our y to the power of 2, there plus our x, y, there plus our x squared close bracket equal to 91. Easy. Okay, now let's look at this again. Because we have this times this, here we're going to bring out all the possible factors of 91. The possible factors of 91 to this system here. Because for us to get all the integer values of our x and y, then we're going to have some possibilities of this being equal to the all the factors of 91, and this equal to the factors of this also. So what does that imply? It means that the factors of 91, we have 91, we have 1, we have 7, we have 13, then we have 91. Okay, so these are the 4 factors of 91. So for the integer solution of this expression here, so we're going to have this to be either we have a y minus x will be equal to our 1, 7, 13, and 91, and our y to the power of 2 plus our x, y, there plus our x squared will now be equal to 91, 13, 7, 1, respectively. Okay. All right. So from here, what do we do from here now? So we're going to take the 4 different cases here now, because this is case 1, case 2, case 3, case 4. So we're going to take case 1 today. So we have here case 1. What is our case 1? Our y, we have y minus x will now be equal to 1. So let's take this as equation. Let's take this as equation 1. Then what is our equation 2? Our equation 2 will be y to the power of 2 plus our x, y plus x squared will now be equal to 91. Okay, now let's give this equation 2. So from equation 1, what we do here is easy. Let's make y the subject of the formula by moving x minus x to this side of the equation. So if we make y the subject of the formula from equation 1, so we're going to have y will now be equal to 1 plus our x. Let's give this as our equation 1 star. Okay, so let's continue on this side. All right, so from our equation 1 star, we want to put the equation 1 star into equation 2 here. So wherever we see y, let's put in this expression. So this is going to imply, this now implies, here we have bracket 1 plus our x all to the power of 2, then plus our x into our 1 plus our x close bracket, then plus our x squared, everything equal to 91. Okay, so we cannot solve this systematically. So if we open up this is going to give us our 1 square, which is the same thing as 1, plus our 2x. Then this will now give us plus x squared, plus we use this to open this x, plus our x squared plus x squared equal to 91. So we can add all the 10 that are having x to the power of 2. This 1, 2, 3. So we have here 3x to the power of 2. Then 2x plus 1x will give us 3x. So we have here plus 3x. Then plus our 1 here. Move this to this side to give us here minus 91 equal to 0. So this will end up giving us our x squared plus 3x, then minus 90 equal to 0. You discover that 3 can go through all the terms we have here. So we divide by 3, divide by 3, divide by 3. Divide this by 3, of course, will give us 0. So we're going to have here x to the power of 2 plus x, then minus, it's going to give us 30, right? Yeah, 30 equal to 0. So this is a quadratic equation. We can solve this quadratically, right? Okay. So from the factors of 30, we look for 2 of them that when multiplied together will give us minus 30. Add together will give us x. That will give us plus 6 and minus 5. So this is going to give us x squared, then minus 5x plus 6x minus 30 equal to 0. We can group this, group this, group this, group this, and factor out x here. So if we factor out x, here we're left with x, minus here we're left with 5. Then what is common here is 6. So 6 here we have x. Then 6 into 30 will give us here 5 plus bracket equal to 0. So the terms in the two brackets are the same. So we can take this inside and take this outside. So we now have this to be our x minus 5 plus bracket around x plus 6 equal to 0. So if we succumb to the zero product rule, we can equate this to 0, equate this to 0. So we're going to have here x minus 5 equal to 0, or our x plus 6 equal to 0. So end up having our x1 is equal to 5 and our x2 is equal to minus 6. Okay, so let's go ahead and find the corresponding value for our y. So we consider equation 1 star. So from equation 1 star, here we know, we have to record that our y from equation 1 star is equal to 1 plus our x. So when x is 5, what will be the value of y? So we're going to have this to be y1 as this one, sorry, x1 as this one, take y1. So this is equal to 1 plus our 5. And 1 plus 5 will give us 6. So that's our y1. And we look for our y2, going to give us the 1 plus x2, which is equal to, what is our s2 is minus 6. So we're going to have here 1 minus 6, which is equal to, going to give us minus 5. Okay, so let's just bring out the value of our x and y from the system here. So we have our x1 is equal to, our x1, we have it to be 5. Then our x2, we have it to be minus 6. y1, we have it to be, what is our y1? 6. The y2, we have it to be what? We have it to be minus 5. Okay, so let's keep this result. And then we now take our second case scenario where we're going to have this expression to 7 and this to 13. So let's consider case 2. Now here we are having y minus x equals to 7 and y squared plus xy plus x squared equals to 13. Again, we want to make here y the subject of the formula. So we're going to have here y will now be equal to our 7 there plus our x. So let's hold this equation here and yeah, we want to put the whole of this equation into this second equation here. So whenever we see y, let's put in 7 plus x here. So this now implies, here we have y squared, so we're going to have 7, then plus x r to the power of 2, then plus our x into 7 plus x plus bracket, then plus our x squared equal to 13. Correct. We can expand this, right? So if we expand this, this is going to give us 49, right? Then you're going to have 7x times 2 to give us here plus our 14 x, then plus, here we're going to give us x squared, then plus, here we have 7x plus our x squared, then plus our x squared equal to 13. Okay, so we can add all the 10 that are having x squared together here now. So we have here 1, 2, 3 of them. Okay, so this is going to give us 3x to the power of 2. Then we will have 14x plus 7x. This will give us 21x. So we have here plus 21x. Then here we have 49. So plus 49. Yeah. Then bring this to this side, minus 13. Everything equal to 0. Again, so we can simplify this, right? So this will now give us here 3x squared plus 21x. Then this from this will give us a 36, right? So we have here plus our 36 equal to 0. Again, we discovered that we have 3 common to all the terms here. So let's split or divide through by 3. So if we divide this by 3, this by 3, this by 3, and this by 3, this by 3 will give us 0. So automatically, we're going to come up here, we'll have here x squared, then plus 7x, then plus, here we have 12, right? 12 equal to 0. This is another quadratic equation. So let's look for two numbers that when we multiply together will give us plus 12, then their addition will give us plus 7. Automatically, from the factors of 12, we're going to have 4 and 3. So we can rewrite this middle term as our x to the power of 2, there, plus 3x plus 4x plus 12 equal to 0. So we can now group this now. I bracket this, put this in bracket, also put this in bracket. We discovered that there are some terms, also variables, and some numerals that are common to this and here this. So let's factor them out and see what this gives us a term. So let's continue on this side of the board again. So let's factor out and see what this gives us. So here x is common. So you're going to have x into, here we're left with x plus, here we have 3. We have 3 here, close bracket. The plus here, 4 is common here. So we're going to have here 4 brackets. We have x left, and here 3. Okay, everything equal to 0. So again, we take this, one of these, and take this outside. So we now have x plus 3 plus bracket, bracket x plus 4, everything equal to 0. Applying the 0 product rule again, we equate this to 0, equate this to 0. So we have x plus 3 equal to 0, or our x plus 4 equal to 0. Therefore, we have our x, this time is going to be our x3 will now be equal to minus 3, and our x4 is equal to minus 4. So let's go ahead and look for our y3 and y4 from which of the equations? From this very equation here. Okay, so we're going to take this equation here. So now say recall that our y is equal to 7 plus our x. So we have our y3 will now be equal to 7 plus, what is our x3? Look at our x3 is minus 3, which is equal to 7 minus 3, which is equal to 4. So we have our y3 to be 4. Okay, then here we look for our y4. Our y4 will now be our 7, the plus bracket minus 4. So this is equals to our 7 minus 4, which is equals to 3. Okay, so let's include these solutions to our existing answer. So have our x3 will now be equal to we'll solve for our S3 to be minus 3, then X4, we'll solve for it to be minus 4, then our Y3, we have it to be, where's our Y3? We have it to be positive 4, and our Y4, we have it to be what? Positive 3. Yeah, the essence of bringing all this out so that at the end of the day, we can bring out all the roots, all the solutions together in a concise form, right? Okay, so let's take our case number 3. So we have case 3. Let's see if something good will come from case 3. What will be our case 3? Case 3 is going to give us our y minus our x will now be equal to our what? That will give us 13. We're going to have here 13. And from here, we're going to have this to be, make y the subject of the formula. This is going to give us here our 13, then plus x. So let's hold this equation. Then we now look for our second equation, which is going to be our y squared, right? Okay, so we're going to have this to be our y squared. So from here we have our y squared, the plus our xy, the plus our x squared. First of this is going to give us our 7. So let's put the whole of this equation into this. Then this is going to give us, this now implies, here we're going to have brackets, our 13 plus our x r squared plus bracket our x into, here we have y is 13 plus x plus bracket, then plus x squared equals to 7. So if we open up this, will give us a 169, the plus, here we give us 13 plus 13, 26. So we have 26x plus our x squared, then plus this will give us 13x plus x squared plus x squared equals to 7. Okay, again, we can add up here. So we have 1, 2, 3 of x squared. So we have a 3x squared, the plus, here we have 26, and here we have 13. So if we add this to that, will give us a 39. So we have here 39 is 3, please. You write it where. So here we have 39x, then here we have plus 169, yeah, then minus 7 equal to 0. Okay, so let's just subtract and see what this gives us. We have 3x squared, the plus your 39x, and if we take this from there, this will give us 162, so we have plus 162 equal to 0. Again, we can use 3 to divide through, right? We can use 3 to divide through everything here. And so let's do that and see what this gives us. So let's continue on this side. So let's divide by 3, divide by 3, divide by 3. So if we do that, we're going to have this or to be our x squared, the plus, so and 3 here will give us 13. So we have here 13x, the plus, the 3 here will give us 5, 4, right, equals to 0. Again, this is a quadratic equation, so we have to check if this will give us a real solution or an integer solution. Okay, so how do we get that? So let's check using our delta. You know, this will give us b squared minus 4ac. So what is our b? Our b is the coefficient here, coefficient of x. So we're going to have 13 squared minus 4 into our a is the coefficient of x squared, then into our c is 54. Okay, right. So from here, this will give us 169 minus this time this will give us 16, then 20, there's 216. All right. So let's subtract and see what this gives us. This will give us 7. The year 0 will give us minus 47. So we have minus 47. All right. So here we have our delta is equals to minus 47, and this is less than 0. So there is no integer solution or real solution from here. Here we're going to have imaginary root from here. So there is no solution here. So here we say no solution here. Okay? No solution. And if you do that for case 4, our case 4, whereby we're going to have our y minus 13 to be our 91 and this other fraction to be a 1, there will be no solution also because we're going to have imaginary root from there. So what are the solutions or the pair of x and y that are the integer solution to this math challenge here? So let's bring that out from here now. So we can now say therefore in R we now have our bracket x comma our y will now be equal to the first pair. So we have here x5, so we have here 5. Then where's our y1? Y1 is 6. Then we have our x2, we have minus 6. Then y2, we have minus 5. Minus 5. Then we have our x3, we have minus 3. Then we have our y3, we have 4. Then lastly, we have our x4, we have minus 4. And our y4, we have positive 3. Okay. All right. So these are the pairs of x and y that will satisfy this challenge here, this math problem. So this brings us to the end of this math challenge. If you learned something good from this math challenge, give the video a thumbs up. And if you have any question with regards to this approach applied here, then drop it in the comment section. Okay, we'll reply to your comments. Remember, this is OnlineMaths TV, and we all here, we love you so much. Keep winning until we meet you in our next class. Bye for now.